Thank you for the introduction, Adrian. Thank you for having me. Yeah, I'm Luke. I am from the CNCF, the Cloud Native Computing Foundation, which, if you're not familiar with it, is it's basically like the Apache Foundation. So it's like a nonprofit open source foundation with pretty significant backing by major tech companies and orgs. But with a specific focus, which is on the so-called cloud native paradigm, which is a very controversial, kind of nebulous thing, but it's basically stuff having to do with containers and Kubernetes. So I will I will give a bit of a disclaimer before this talk. I just started working at the CNCF about 4 months ago. And my talk tonight is going to be about two technologies that I don't know a super duper amount about. So it's going to be a little bit more of a high level thing where I just, give a 500-foot overview of Prometheus and Cassandra and how they work together. And I think it's more of a suggestive talk. Like here's some stuff you might think is interesting. Here is some potential fodder for future independent exploration. So a little bit about me. Like I said, developer advocate at the CNCF. Developer advocate is, of course, is also a very nebulous position. In my case, I mostly write documentation and blog posts and build websites and things like that, because it turns out that those tend to be the things that open source projects need the most and know the least about how to help themselves, to put it a little bit bluntly. In terms of databases, I do know a thing or two about databases. I authored the second edition of the 7 Databases in 7 Weeks book, which some of you may be familiar with. It covers one SQL database, which is Postgres, and then 6 just sort of for the sake of comparison, and then 6 NoSQL databases. So we got Redis, MongoDB, CouchDB, Neo4j. Did I say HBase? HBase. Originally, React was in the first edition, but we scrapped React for the second edition and did DynamoDB instead. So if you want a book that gives you a real like 10,000-foot overview of things, I think that's a pretty good place to start. A database that the book does not cover is Cassandra, because we, I guess with previously React and then Dynamo, we felt like that sort of sub-paradigm was already covered in the book. Maybe in the 3rd edition, I mean, now that Cassandra has become so well established, maybe in the 3rd edition we'll throw that one in as well. But, sorry? It'll be 8 databases. Yeah, well, the problem is that there's already this like 7 languages, 7 databases, 7 containerization, 7 configuration languages. That's a book I want to write one of these days. Yeah. Also, I live in Portland these days, but I am a native Washingtonian, and I'm very proud of that. For a long time, I flirted with the idea of Cascadian separatism, and then one day I realized that I think I'm just a Washington State separatist. Maybe I don't care as much about the rest. Anyways, always good to be back in the home state. Always good to be back in Seattle. So a basic crash course in Prometheus. Has anybody here not heard of Prometheus? Okay, so it's going to be familiar to some degree to all of you. So if you're like super dialed into Prometheus, maybe just I don't know, do something else for the next 20 minutes, because I'm giving a pretty high level overview. So Prometheus is an open source monitoring and observability tool. It is actually the second graduated project under the CNCF. So Kubernetes, unsurprisingly, was number one. Kubernetes was the project that more or less is coterminous with the birth of CNCF, super duper important. But Prometheus is coming in right at its heels. It was originally built at SoundCloud in 2012 in Germany, and actually the dev team is heavily German. I was just at PromCon in Munich a couple months ago. It was super fun. And one thing that I like about the community, well, actually 2 things that I like about the development, the core development team, is that it's not dominated by any single organization. So we all know these open source projects that are that are like nominally, ostensibly open, but really there's like one or two like really heavy hands guiding things. With Prometheus, that's not at all the case. In fact, some of the core community members are basically contractors who run their own observability and monitoring startups and consultancies. The other thing that I really like is that it's a pretty conservative development culture, and I don't mean that politically. I just mean in terms of their sensibility and their approach to the project. They're very much into not going all in on new features and bells and whistles and flashy things. They're much more about staying on a very narrow path and not allowing the project to succumb to bloat, which we see in a lot of cases where, connector to this and integration to this, connector to this, integration to this, and what you get is a big mess. Prometheus is very much not that, which I appreciate. It's written in Go. It's gotten pretty widespread adoption. So it's been around for 6 years. It's been in the CNCF for a few, and it's used by, if you pull up the Prometheus.io page, the list of users is pretty crazy. They use it internally at Google, DigitalOcean, Apple, all over the place. It integrates with just about everything, including Cassandra. So you look at the integrations list, and every major database you can imagine is represented, so on and so forth. It is a scrape-based metrics gathering system. So in contrast to, I guess, what you would call push-based metrics gatherings, where processes emit metrics to a thing over there. Instead, the way that Prometheus works is that your processes, whatever they are, offer up metrics that are scraped just through an HTTP port in a very simple text format, which is also a little controversial, but we'll talk a little bit about that. So in terms of how the data actually works, it's this label-based time series data system. So you see HTTP request total, job equals web, instance equals web1, env equals prod. So it's this very kind of key value oriented way of specifying time series and choosing which time series you want. I'll talk a little bit later about the sort of the other paradigm of querying time series data, which is more hierarchical and I think like objectively worse, but that's open to interpretation as well. So this is the basic format for exposing Prometheus data, and then PromQL is more of a sort of a high-powered querying and analytics language that you can use to actually do things with this time series data. So in this case, we're basically what are we doing here? So we have total HTTP requests potentially across all jobs, instances, and environments in the last 5 minutes, a sum of the rate, and then you're doing like the bottom three. So whichever three and then sorted by app and process. This is all, this is very abstract. I actually don't even know what this represents, but this gives you an idea of what PromQL looks like. I'm getting a phone call. No. Okay, in terms of the basic architecture of Prometheus, so this is actually borrowed directly from the Prometheus docs, which I actually don't feel bad about because I made it. So if you see it on the webpage, that's actually my work. So you'll see that a Prometheus server, which you see in the middle, is typically part of kind of a mesh or a framework of other services. It's very rare that you would use Prometheus just on its own, run it as a server. So I'll talk a little bit about some of these components later, but typically what you'll see in conjunction with Prometheus is the alert manager, which I think is probably the most commonly used one, which manages the actual, I guess you could say, observability portion of Prometheus. So the alert manager basically takes in alerts that are fired off by Prometheus, and you can configure conditions under which alerts are fired, and you can assign severity levels to those alerts. And then alert managers is responsible for actually handling them. So where do they go? So what happens? Do they get sent to email? Do they get sent to PagerDuty? I'm sure that there's some kind of, I'm sure people have built Twilio integrations and so on and so forth, where you could get actual like literal pages or literal text messages, so on and so forth. Some other things, which we'll get into later. Prometheus does come with its own web UI. In terms of visualization, Grafana, which is not technically part of the Prometheus project, is typically used as the visualization system. I haven't really seen any others used with it, although there might be others. If there are, please let me know. I'd be very curious. The push gateway is something that I think is not used all that often, but if you have short-lived jobs, remember that Prometheus is a scrape-based system. So if you have a short-lived job that dies before Prometheus is able to scrape it, what do? Well, what you do is you have those jobs pushed to this push gateway that gathers them, keeps them, and makes them available for Prometheus to come along and scrape at whatever specified interval. So yeah, we'll get more into these components as we go along. So yeah, the push gateway. The alert manager, which like I said before, you basically, there's two levels of configuration that you use here. So one of them is that you provide Prometheus with configuration that determines what actually counts as something deserving an alert, and you use PromQL for that. So like whatever kind of PromQL statement you can think of, if disk space usage is, if the rate of disk space usage over time is expected to achieve some undesired level, for example, over the course of 5 minutes, then you fire an alert with a severity of critical or warning or notice or caution, for example. The alert manager has, I think, some really interesting capabilities built into it. One of them is Inhibition Rules, which is basically, it allows you to hierarchize your alerts, which makes a lot of sense if for example, in a Cassandra context, if you have like an entire cluster down, you can say that that's a more important alert than, for example, one of the nodes running out of disk space. So imagine if at the same time you're getting messages on PagerDuty that your Cassandra cluster is down and also that one of the nodes is running out of disk. I mean, who cares about the node running out of disk if the whole thing's unavailable? And so inhibition rules enable you to sort of to prioritize in that way. You also have silencing rules, which enable you to temporarily silence certain things. And you also have a handful of built-in notification targets. I mentioned two of them before. Another one is Slack. And I think most importantly, and I put it in bold, is that you can actually send notifications, alerts to custom webhooks. So you can just give the alert manager a URL endpoint, and the alert manager will just post some JSON, which I think is a really interesting and really compelling way to extend and customize your Prometheus setup. Another one, of course, is, like I said before, is Grafana dashboards, and I'll show you an example of one in a little bit here. This is the Blessed visualization solution. I've never seen another one used. And a cool thing about Grafana dashboards is that they do allow for a classic sort of click and drag interface for putting together dashboards, but you can also build your own via JSON. That can be a very unwieldy process. I mean, I've seen these JSON blobs that are like 200K or something, but it's also really easy to basically share them in line, like make them available through the Grafana webpage, and sort of click and drag, and it's all pretty nice. So I'll get into some of the arguments for. I mean, I'm here with the CNCF, and I do need to talk it up a little bit. So these are some of the things that I personally find most compelling about Prometheus, and I imagine there are others in the community that agree. So one of them, I think, is the operations story is pretty solid. So you basically have this single static binary that you can just fetch, untar, and go. Obviously, a programming language like Go makes that borderline trivial to build and distribute, which I really like. You have on-disk storage via TSDB. I'll talk a little bit more about that, which is the time series database that underlies Prometheus. And I think the advantage of that on-disk storage is that you don't have to stand up a database beside it to make it run. So you don't have to run it alongside Postgres or Cassandra or anything like that. You just have these independent units that you can put up on a server or a VM somewhere, and all of the storage is handled for you. Another thing that I really like that you definitely do not get in Java land, like you definitely don't get this with Prometheus, is that you can restart the server and do a configuration reload in two ways. You can either use kill, or you can just do an HTTP post to certain /-/reload. And it typically restarts in like 200 milliseconds or something, which is really nice. So if you need to do some kind of rolling configuration change across instances, some kind of rolling upgrade, or so on and so forth, you can do that really super easily, which I'm sure a lot of you working in distributed systems and ops and SRE things, that's not the most common thing, to be able to trigger configuration reload that quickly. It also has a built-in expression browser, which is not the prettiest thing. It's not the most up-to-date React.js hot thing, but it works pretty well, and it just runs as an HTTP process. So as I said before, I talked about the label-based time series querying, and so I basically so this top one right here is a label-based query, and the one below it would be a hierarchical query in a system like statsd querying. And they're sort of functionally the same, but you'll see that with the hierarchical system for querying time series data, you basically, there's an implicit positionality of the different elements. So you basically, if you forget the order in which these things are arrayed in the expression, then you're pretty much sunk. So that essentially means that shoot, what was I going to say? I forget what I was going to say. Anyways, so I mean, to me, I think that as far as I can tell, the entire monitoring ecosystem time series querying ecosystem is moving firmly away from this kind of hierarchical querying. There may be holdouts, there may be advantages that I'm not aware of, but I think that that this label-based system, which is very much a key value kind of paradigm for fetching time series, seems to be really carrying the day, and Prometheus seems to be a leader in that space. A couple other things. So like I said, there's this, actually I shouldn't say in-memory storage. It's on-disk storage. I actually don't remember if TSDB is in memory, so don't quote me on that. It's based on Facebook's Gorilla. So it's this heavily optimized time series database. It also has, so Prometheus has a variety of service discovery mechanisms built in. So one of the hard problems in just in the monitoring space in general is just knowing where your targets are. So if you have hundreds, if not thousands of targets, then how do you make sure that Prometheus knows where they are at all times? And there are a bunch of built-in mechanisms for doing this. You can do basic Kubernetes service discovery via the .default, .svc, .whatever system, whatever the weird internal DNS system in Kubernetes is. You can use console. You can use standard DNS. Or one that I find super interesting is you can actually use JSON files for service discovery. So you can basically say, so you can just, in your service discovery configuration, you can point to a JSON file and list IPs and ports alongside that. And which is already fairly compelling, but what I find more compelling is that if you change these, if you change the contents of one of those JSON files, then Prometheus will actually recognize the change and do some kind of internal auto refresh in terms of where the targets are. So I've seen, when I was at PromCon in Munich a couple months ago, there were actually a bunch of talks about how all these big companies like Fastly had all these crazy like sidecar processes that were doing real-time service discovery updates via JSON files. So, some kind of, either like a Kubernetes, pod sidecar or some kind of, agent running on a particular server is actually, has a sole task of keeping these JSON files up to date at all times. So I think that's another very cool customization thing. So, and finally, amongst the, this is not going to be like 5 parts, just 2-part why Prometheus, is that you get just tons of customization. So, like I said before, the development culture around Prometheus is a very, very conservative one. They're not interested in adding feature after feature after feature. They want to, their goal is kind of the same as the Kubernetes core team, which is basically they want to just have a feature set that's done forever. And I think they're just about there. Well, with one exception we'll talk about. And instead, they've very much gone down this customization route. So you can set up your own alerting webhooks if you need to, instead of hard coding a bunch of alerting targets into Alert Manager and getting that static binary bloated to like 150 megabytes. Instead, they just let you write your own. There's also a remote write API. Take a drink of water really quick. There's a remote write API for long-term storage. So Prometheus does not actually provide any long-term storage. You can configure how long you want your data to stay in a particular Prometheus instance, but it's not designed to keep your data around forever and to run super complex queries on data that's a month old. It's meant to basically take in as much data as you say for it to take in, process it the way it needs to process it, potentially fire off alerts, and then just let it go after a while, or potentially write it to a long-term storage solution. File-based service discovery is another one that I just mentioned. I am not aware of any other systems that do file-based service discovery in this way. Does anybody know of one? Where you can update a file and that change is instantly noted by the system and taken. Yeah, I haven't seen them before, which is super cool. And of course, custom exporters. So lots of things, including Cassandra and every other major database and major distributed system thing that you can think of has a Prometheus exporter, and you can also just create your own. So as long as you expose an HTTP port that's scrapable by Prometheus, and you expose your metrics in the Prometheus text format, then you have written a Prometheus scrape-compatible service or process. So some of the drawbacks of Prometheus, and of course I put the asterisk because drawbacks really depend on your perspective, and some of the so-called drawbacks are actually a product of very conscious decision-making on their part. So there's no built-in long-term storage. It's not designed for that. It's not built around that principle. It's also not, importantly, it's technically not a highly available system. So each Prometheus node is like an independent sort of universe. They're not built to work in conjunction with one another. They're not built to work in a cluster. You don't get NRW, read-write quorums, specifics or semantics or anything like that. You get high availability by just running lots of them. And if you lose one, you just hope for the best, that there's still enough left. Which is also, I think, a very conscious decision on the part of the developers that when you start building systems to operate in terms of Paxos or Raft or whatever consensus algorithm, they get really hairy really quickly. They produce all kinds of headaches for operators and SREs and sysadmins. And so no built-in long-term storage is a drawback, but like I said, there is a remote write API that you can use to to fan out Prometheus data into any kind of system you want. So some of the major commercial providers include InfluxDB, which I'm sure a lot of you are familiar with. They have, I think, a pretty good Prometheus story. There's an open source project called TSDB, a time series database. You can use actually other systems like Graphite for that, so on and so forth. And yeah, basically you can shell that data out any way you like with the API. This is also a little bit controversial, but there's no built-in security. So this is another design choice that keeps that static binary nice and lean and keeps it very, quote unquote, I guess, operationally simple. But it also means that, that any security that goes on around Prometheus has to be provided by you. So it basically assumes that every request and everything coming to it is coming from some kind of trusted, non-malicious, non-malignant source. And yeah, the responsibility is on you to keep it that way. So the drawback, of course, is that that's another operational thing that you have to worry about and take care of. But I guess the advantage is that if you have some crazy like Kerberos level 10 internal security system, that you don't have to, that the Prometheus maintainers don't have to worry about covering that. Another drawback is the plain text metrics exposition format. Now, it's a super simple format. I showed you a couple examples, but one of the criticisms here, of course, is that it would probably be a lot faster if the metrics were exposed via protobuf or something like that. Some kind of more efficient encoding would probably be better. Which, yeah, I suppose that is a drawback, but it does have the advantage that that writing your own libraries that work with your own language-specific libraries and clients for Prometheus is super easy because you're just writing plain text and not having to do your .proto something or other. And then finally, one drawback, I guess, is that it tends to be just one piece of a puzzle. So this is not like an all-encompassing, all-in-one tool that's meant to serve every purpose. There's no built-in dashboard. You use Grafana for that. There's no support for logs or tracing. So if you want to deal with logs, you're going to have to do a Logstash, Elasticsearch, something or other. If you want to do tracing, you're going to have to do Jaeger, some kind of open tracing compatible thing, etc. So in terms of how Prometheus and Cassandra would play together, I put together this little diagram right here. So here's a hypothetical Cassandra cluster right here. And I guess that the interesting key part right here is this, which is that Cassandra metrics are actually exposed via Jmx. And there's a Jmx Exporter that you can run as a kind of a sidecar agent on the same JVM as your Cassandra node. Now, Adrian informed me right before this talk that apparently coming from the DataStax universe, for DataStax Enterprise, there's going to be some very interesting stuff happening sometime soon. But maybe Adrian can say something about that later. But so you have a handful of Prometheus instances running here, and remember, they're not running in HA, they're not clustered or anything like that. They're just these kind of autonomous, autarkic processes doing their thing. And each one of these instances, and this is where things get a little bit chatty. The diagram is simplified, but basically, you're going to have each of your Prometheus instances scraping each one of your Cassandra nodes all the time. So there is a lot of redundancy built into that, but again, if each of these Prometheus instances is autarkic, the way that they necessarily are, then there isn't really any compelling way around that. And then you have web clients connecting to Prometheus right here, so that can be the Prometheus dashboard, Grafana, so on and so forth, and then pushing out alerts to Alert Manager, which then does whatever with them. So I'm going to dig a little bit more into this, into the scraping part. So basically, for Cassandra, the mbean concept is where everything begins. In Cassandra, you have a bunch of mbean families, org.apache.cassandra.whatever. Well, all the Prometheus metrics are in this .metrics subfamily. And so the Jmx Exporter, what it essentially does is, so the problem with mbeans is that they expose metrics in kind of a similar way, but the names are just a completely different, of a completely different species. And so what the Jmx Exporter does is it just renames each of your mbeans, and you can actually specify via configuration how that renaming transpires. So here's an example of like one of the default rules, which is where if you have org.apache.metrics and then colon, which actually kind of plays well with the label-based naming system, type, name, you would end up with this as your Prometheus metrics name. And then, so from there, the metrics names are transposed, and then the metrics are exposed via HTTP by the Jmx exporter running in the same JVM. And then from there, they get scraped by Prometheus, and then you can do all kinds of fun stuff with them via PromQL, and you can make all kinds of cool dashboards and things like that, which we'll do in a sec. Yeah, so here's kind of a somewhat prettier picture of what I just explained. So you have your mbeans kind of like embedded inside, enmeshed inside of your Cassandra process, shelling out to the Jmx exporter, which is renaming the metrics and exposing them via HTTP. So yeah, here are some examples. Obviously, I'm not going to like go through these specifically, but you see that there are a bunch of metrics that are Cassandra specific, having to do with the cache, with disk space usage, with client connections, with client request failures and successes. There are metrics for CQL related things, and then also something like 15 to 20 JVM specific metrics that you get access to. So if you want to know how much memory your JVM is using, how many threads are current at a given time, and so on and so forth, this is all exposed up to the Prometheus level. Here's a handful of PromQL queries, which I copy and pasted. I'm not sure what they mean, but that's what they look like. And here's an example of an alert manager rule that you might write for for Prometheus. So you have this named alert approaching capacity, and you take a metric like Cassandra storage load, and you say if it has exceeded a certain number for over 10 minutes, then you need to fire an alert at the caution level. And then you can apply some actual text. So disk use approaching capacity in Cassandra instance, blah, blah, labels.instance. And what this thing is right there is that's actually the Go templating system. So I don't know if any of you have used the Go templating system. I use it a lot because I use Hugo, the static site generator, a bunch. It's a very weird, very unintuitive, but also very powerful templating system. So if you're used to Jinja and like liquid templates and things like that, it's going to be a completely different species of thing. So I wanted to also talk a little tiny bit about what's currently going on in the Prometheus community. So one of the things that's coming on the way is built-in security. So we actually talked about this at the Dev Summit in Munich a couple months ago, but things like basic auth, TLS, and a handful of other mechanisms like maybe JSON Web Tokens, maybe Spiffy, which is a certificate-based system. But one way or another, you will soon be able to apply some actual security to your Prometheus instances without applying your own proxy layer or something like that. The Open Metrics project is a new CNCF project in the sandbox right now. It's basically attempting to take the Prometheus exposition format that we saw and turn it into a neutral standard. And it's actually it's a pretty interesting effort that has a lot of the big players on board. I think New Relic is part of that, Datadog, Sensu, and a bunch of others. So it's entirely possible that in a couple years or even sooner, this will emerge as the de facto standard, and which would enable you to basically which would enable you to write once and forget. That basically, as long as your processes and your systems are exposing open metrics compliant format, then you can mix and match and pick and choose whatever endpoints or systems you're working within. So it was originally based on the Prometheus format. OpenMetrics is also going to have a protobuf format. So if you're concerned about the efficiency of plain text, then I suppose help is on the way. And right now there's an effort underway to actually to bring the OpenMetrics process back into Prometheus itself, and to make that a sort of a mutually enhancing process. In terms of long-term storage, which I talked about before, Cortex is also a new CNCF project in the sandbox, and this is a long-term storage endpoint for Prometheus. This is very much like a multi-tenant, horizontally scalable, clustered system with NRW, quorum, so on and so forth. A very complex thing. So if you need that kind of scalable long-term storage for Prometheus, and you want to do crazy analytics, and you want to look at data from 5 years ago, Cortex is emerging as the de facto open source way to do that. It writes to a bunch of backends. DynamoDB, I forgot to put S3 on there. That's one of them. So Dynamo, Cassandra, Google Cloud Bigtable, and then and then like Adrian just told me, apparently there's some DataStax Enterprise thing that's going to give you long-term storage of Prometheus data, but I don't know much about that. So, but I figured I'd mention it. Yeah. So that's it for now. Or actually, before I go, I'll just pull up an example. Oops. I don't know how to get over. Can I go? I need to. Oh yeah, I'll just pull up an example dashboard running locally. So if you want to get a super pretty picture of what's going on in your Cassandra cluster, this is just a single node. So some of these aren't super interesting. Unsurprisingly, the cache capacity, for example, is not really doing much, given that there are no reads or writes. But yeah, so that's what that looks like. And that is pretty much it for me. So all right, that's it. Thanks.